Good morning, students. Am I audible?
Good morning, sir. Yes, sir, you're audible.
Okay, thank you. So, so we move on to the next numerical. Okay, in the same chapter, uniform flow. So this is our next numerical. So I suggest you to just write down the question. Okay. So here we have to show that. Okay, or you can say we have to prove. Okay. So what is given? We need to prove about the normal depth thing nothing but is you can write y, okay, in a triangular channel. So it is given as a triangular channel. Side slope is given, z horizontal is to 1 vertical, okay, and this is the expression. So what we have to do, we have to prove that yn, that is our normal depth in a triangular channel, when the side slope of the channel is z horizontal is to 1 vertical, is followed by this expression, okay, is followed by this expression. So kindly you write down the question. Okay. Over. Okay. So this is the equation we need to prove. Okay. That is yn is equal to 1.189 multiplied by, this is discharge, multiplied by Manning's coefficient. Okay. Small n divided by root over base slope to the power 3 by 8, again multiplied by z square plus 1 divided by z to the power 5 to the power 1 by 8. Okay. Okay. So you can draw this diagram. Okay. It's a triangular section. It's given the equation. Then the side slope is given. Z horizontal is to 1 vertical. Okay. Z horizontal is to 1 vertical. So that is why we have taken 1 by Z. 1 is to Z. Okay. 1 vertical and Z horizontal. Okay. The whole angle for that particular triangular section we have considered theta. Okay. and this line, the dotted line we have seen, it's divide the whole triangular section into two parts. Okay, so that is why it also divide the angle theta into two equal half. Okay, so for this side your angle is theta by 2, and for the other side it is again theta by 2. Okay, then we have marked this point as A, this is your B, and this point is C, that is your bottom of the channel, and this point is nothing but your D. Okay, and the depth of flow we have considered Y. Okay, so similarly we have already discussed this will be your YZ, or you can say ZY. Okay, same thing, ZY, and this is also ZY. Okay, from here to here is ZY, and from here to here again it will be ZY. Okay, okay, so now we are going to consider this triangle. Okay, this triangle. So definitely this is your 90 degree. Here it's 90 degree. Okay, so we draw like this. Okay, this is your 90 degree. So the 90 degree is at point A, right? So this will be your A. Okay, and this will be your B. So this is your B, and this is your C. We join. Okay, so this is a right angle triangle. You can see here. This is your 90 degree. This is a right angle triangle. Okay, so here A B is nothing but your ZY. Okay, or you can say YZ. It's up to you. A B, that side is your YZ. Okay, and A and C is nothing but your depth of flow. AC is nothing but your depth of flow, that is Y. Okay, that's why we have taken Y here. Okay, and we have already discussed the whole angle C. Okay. So that's why this angle is theta by 2. This angle is theta by 2. Okay. So we are considering this triangle, and we have the two side, and we are going to find out the other side, that is your BC. Okay. So definitely we are going to use our Pythagoras theorem to find out the side BC. Okay. So there is nothing but our square root zy square plus y square. Okay. So here that y square, and again we have y square, so we will bring it out and we will get y root over z square plus 1. Okay. Z square plus 1. Okay. Z square plus 1. This is nothing but your BC, this side. This is nothing but root over z square plus 1. Definitely we have a y. Okay. Y root over z square plus 1. Then we are going to consider tan theta. Okay. Now we are going to consider tan theta. Then here the theta is nothing but theta by 2. Okay. So tan theta is equal to perpendicular by base. Okay. Perpendicular by base. And then perpendicular is nothing but zy. This is our perpendicular and this is our base. Okay. So perpendicular is zy and base is y. So this y is will be cancelled out, or what will be left out is z. Okay. So we can directly write here tan theta by 2 is nothing but z. Okay. So similarly, we are going to find out sec theta by 2, that is BC by y. So BC we have already calculated, y root over z square plus 1 and then divided by y. Ultimately, we are getting root over z square plus 1 for sec theta by 2, and for tan theta by 2 it's z. Okay. From here you can also write BC is equal to y sec theta by 2. Okay. You write down its expression from here. Okay. As sec theta by 2 is BC by y, so you can write BC is equal to y sec theta by 2. And what is sec theta by 2? It's root over z square plus 1. Okay. Okay. So now we are going to consider the area. Area. Okay. Area is nothing but half into base into altitude. So here it is a triangular channel. So the base will be this from here to here, our top width. Okay. In triangular channel, our bottom width is 0 and we have top width. Okay. So that will be our base. So definitely this is your yz and this is also yz. So that's why we have taken twice yz. Okay. Multiplied by the depth of flow y. Okay. So that is why 2 will be cancelled out and z is there and y into y is y square. Okay. Now considering triangle ABC that we have already did. Okay. Then we are going to consider the weighted perimeter. Okay, for weighted perimeter, this is D. So weighted perimeter is nothing but DC plus BC. Okay, this is our weighted perimeter. This side and this side. Okay, weighted perimeter till here, till the level of water. Okay, so here this is weighted perimeter. Weighted perimeter. Okay, so definitely this side and this side will be same as our side slope is same. Okay, so that is why we have taken twice. We know BC is nothing but our y sec theta by 2, and BC and CD will be same in this case. Okay, because the side slope is same, all the parameters are same. Whatever we are going to get for BC, we will get for CD also. So that is why we have multiplied by 2. Okay, twice y sec theta by 2. Okay, from here you can say BC is nothing but y sec theta by 2. Okay, okay, so we have get an expression for weighted perimeter. We have get an expression for area, that is your zy square. So now we are going to take discharge equation. Okay, see why we have taken discharge equation, because if you see in that expression that we need to derive, you see we have q there. So okay, so somehow we have to bring q in that particular expression. Okay, understood. So that's why we are considering this discharge equation. Okay, so that we can get an q in that particular expression. Okay, so this will be q. Then we have already for area we have equation is zy square. Okay, area is nothing but zy square in this case, and then theta by 2, then theta by 2 is equal to z. We have already. So that is why in place of z we have substitute tan theta by 2. Okay, so that is why area, in place of area we have substitute y square tan theta by 2. Okay, so it's zy square, in place of z we have substitute tan theta by 2. So we can write y square tan theta by 2. Okay, then velocity. Okay, See, for velocity, we have two options. One is Sage's equation and one is Manning's equation. But in that expression that we are going to derive, we have small n. That is our roughness coefficient, Manning's roughness coefficient. So that is why for velocity, we are going to use Manning's equation. So we all know that Manning's equation is 1 by n multiplied by r to the power 2 by 3 multiplied by s to the power half. Okay. So if you see in that expression, we don't have any term as r. Okay. We don't have any term as r. Okay. So we don't have any term. So what we have to do, we have to replace this term hydraulic radius. Okay. So we have n in that expression. We have bed slope in that expression. If you see in that expression, we have a term n, we have bed slope, but we don't have any r. Okay. We have y. Okay. Y is the ultimate parameter that we are going to derive. Okay. For y, what will be the expression? So definitely y will be there, but that r is not required. So what we do, we consider r is equal to area by weighted perimeter. Okay. So in place of r, we are going to substitute a by p. Okay. For area, we have already calculated the expression, derive the expression for area and for weighted perimeter also. Okay. So in next, our left hand side we have q, and then what we are going to do, we bring n and our bed slope in the left hand side. Okay, of this equation. So if we bring it left hand side, as it is in divide, we have to multiply it here. Okay, you can see here q multiplied by n. Then if we bring here, it will again divide root over sb. Okay, you can write simply as, or you can write also as b. It's up to you. So it's to the power half, or you can write root over sb. Same thing. Okay, then is equal to this y square tan theta by 2 will be left out. Okay, area multiplied by, in place of r, we are going to substitute a by b, area by weighted perimeter. So area is nothing but we can write this expression again. Okay, y square tan theta by 2, then divided by weighted perimeter. We have already found out the expression, that is twice y sec square by 2. Okay, sec theta by 2. So y square tan theta by 2 divided by twice y sec theta by 2. Okay, so to the power 2 by 3. Okay, so that is y square in the numerator, and denominator we have y. So one y will be cancel out. Okay, then in the next expression, sorry, next line, left hand side will be same. In right hand side, this will be kept as it is. And the second part, y will be cancel out. So that is why y tan theta by 2 twice sec theta by 2 all to the power 2 by 3. Now in the next line, we bring that 2 in the left hand side. Okay, so it will be divide. So we'll bring here in the left hand side, it will be multiplied. And you don't forget, we have 2 to the power 2 by 3. So that is why it will be 2 to the power 2 by 3 is equal to, again, this is already there, y square tan theta by 2 y square tan theta by 2 is already there, multiplied by this y to the power 2 by 3, Okay? So that is why y to the power 2 by 3 and then tan theta by 2 to the power 2 by 3. Okay, divided by this 2 is already we bring it out in the left hand side, so it will be left out sec theta by 2 and to the power 2 by 3. Okay, again in the next line, left hand side we kept as it is, right hand side, so we have y square and here y to the power 2 by 3. So y square multiplied by y to the power 2 by 3. Okay, so is equal to nothing but y to the power, we have to add, right? We have to add 2 plus 2 by 3 is equal to y to the power 8 by 3. Okay, so that is why we have the addition. Okay, we can see this y to the power 8 by 3. Okay, then we have tan theta by 2 here, tan theta by 2 multiplied by tan theta by 2 all to the power 2 by 3. So that is why it's tan theta by 2 to the power 5 by 3. Okay, this is nothing but tan theta by 2 multiplied by tan theta by 2 all to the power 2 by 3. Okay, so we have to add here, we have 1 and this is 2 by 3. So 1 plus 2 by 3 it's 5 by 3. That is why here it's 5 by 3. Okay, and the denominator will be same. So then all the terms except y to the power 8 by 3 we bring in the left hand side. Okay, because we have to derive the expression for y. Okay, so we have kept this y in one side and other all the parameters we bring in the left hand side. Okay, that is why it is in the numerator and this is in the numerator. Okay, then after this we have taken cube in both side. We have taken cube and both side. Okay, so we have cubing both hand side, that is left hand and right hand side. Okay, so that is why 2 to the power 2 by 3 to the power whole cube. Okay, this is also whole cube, then again this time is also whole cube and this is also whole cube. Okay, so this is 2 to the power 3 into multiplied by 3, so 3 will be cancelled out, will be left out is 2 square. Okay, this is cube and then again this 3 will be cancelled out, it will be square and to the power 5. Okay, and this will be y to the power 8. Okay, so we all know tan theta by 2 is z, we have already derived, and sec theta by 2 is nothing but root over z square plus 1. Okay, we have already derived this. Okay, for our this case. Okay, for this numerical, tan theta is our equal to z, and sec theta by 2 is equal to root over z square plus 1. So now we are going to substitute this term, because if you see in that question or in that expression that we are going to derive, we have the term with z. Okay, so we have to bring z in that particular expression. Okay, so that is why here sec theta by 2 is whole square, so we can directly write z square plus 1. Okay, root over will be, because it is square. Okay, so directly we will write z square plus 1 divided by, as tan theta by 2 is z to the power 5 is equal to y to the power 8. Okay, I think this thing you already know, y to the power 8. So if we want to find out y, so we have to multiply each and everything with 1 by 8. Okay, so that is why it will be 3 by 8. Here also to the power 1 by 8, 2 square to 2 to the power 2 by 8. Okay, bring this y in the left hand side. Okay, to get yn. Okay, so after you solve, you will get this expression. Okay, so you go through once again and see if you have any doubts. Okay, if you have any doubts, then we will discuss here. My suggestion is go through once again. Okay, Okay. Next numerical. Okay. Here we have to determine the most economic section. Okay. So those things you have already studied, and I asked to study of your own. Okay, that economic section. So here we don't need a derivation, only we need the condition. What will be the economic section condition for trapezoidal channel? Okay. So this is an example of numericals for economic section. Okay. So what is given here? Determine the most economic section of a trapezoidal channel with side slope is given 2 horizontal is to 1 vertical, carrying a discharge of 11.5 meter cube per second with a velocity of 0.76 meter per second. Okay. What should be the bed slope of the channel? You have to also find out the SP. Okay. And then roughness coefficient is given 0.025. Okay. So first you write down the question. Okay. Then we have to use the economic section condition for trapezoidal channel. Okay. Yes. Okay. Research is given. Okay. Sorry. The velocity is nothing but 0.75. Okay. Velocity is 0.75. To find out the area. So this is very simple. Okay. You just have to use the equation and find out the area. That is discharge is equal to area into velocity. Discharge is already given. Velocity is also given. You can directly find out the area. Okay. Okay. So use area equation to find out the V value width of the channel. That is your bottom width. Okay. So this numerical you try to solve of your own. Okay. This numerical you try to solve of your own, and You can write this for base slope is 2.6 into 10 to the power minus 4. You see if you are getting the same value or not. Okay, base slope is 2.6 into 10 to the power minus 4. Okay, it's very simple. It's not that difficult. You try to solve at your home. Then, if you have any doubts or it is very difficult to find, then we will discuss in the class. Okay, at least you first try to solve of your own. Okay, because this type of numericals you have already solved in third semester. Okay, so I think we have another class. So next class we will start at 11:15. Okay, with a 10 minutes break.